All right, so in this video, we're going to be looking at the inverse trig functions. What they're mainly used for is for solving for an angle rather than solving for a side on a right triangle. So the three main inverse trig functions are arcsine, arccosine, and arctangent. All right, they are right here listed in blue above the trig functions. All right, so it's like sine to the -1 is what it looks like. It's not to be confused with sine to the -1, but what that means is sine inverse, and this one just means cosine inverse or inverse cosine. But what they do is they undo uh, the trig functions. All right, so if I had sine of 50 degrees, and I am in degree mode still, all right, sine of 50 will give me 0.76604 da 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 da. But what the inverse trig functions are good for is, let's say you wanted to do sine of some angle and you wanted to get 0.766044 back as an answer. That's where these inverse trig functions come in. Right? If you do the sine inverse, so second sine, if you do sine inverse of this, it's going to give you back the 50. That's what it does. All right, so if I have cosine of 20 degrees, there we go, and I do inverse cosine of that thing, it's going to give me back the 20 degrees. All right, the relationship is if you have sine inverse of the sine of some angle, doesn't matter what it is, okay, these two things will kind of just clobber each other and cancel each other out. So it'll just give you the angle that you started with, right? And it could be applied the other way too. You know, if you had sine inverse of some angle and you did the sine to that, they would just cancel each other out. And so you would get A again. You know, what they typically get used for is situations like this. Okay, we're going to use an inverse trig function to solve for a missing angle here. So the first thing we do is we're going to set up a trig expression that relates this angle to our known sides. We've got the opposite and the hypotenuse. So I'm going to say sine of angle A is equal to 5/8. All right, and if I want to know what angle A is, I'm just going to do the inverse sine of 5/8. And that's going to tell me that angle right there is 38.68. Okay, so what I would do is I would perform sine inverse to both sides. Okay, I'll do sine inverse of the left-hand side, and I'll do sine inverse of the right-hand side. Well, the left-hand side, these just cancel each other out. So you get angle A is whatever this comes out to be, which was 38.682. Cool. All right. And once you have angle A, if you for some reason wanted to know that angle, just do 90 minus this, and that'll give you this missing angle up here if you needed it. All right. What is the smallest angle for a 3-4-5 right triangle? Okay. Turn this. All right, so we've got a 3-4-5 right triangle. Okay, 3-4-5. And I'm wanting to know this angle right here. Now, I could do sine of A is equal to 3/5 again, and I could use the inverse sine to solve for A. Or I could use tangent. And that's what I'm going to use here. If I use tangent of A, it's going to be 3/4. And if I'm looking for this angle, I would have to do arctangent to both sides, or inverse tangent of 3/4. Inverse tangent of 3/4. There we go, 36.87. So angle A is 36.87. And it's going to match here as well. If I do arc sine of 3/5, it's going to give me the exact same answer. Okay. So if you're ever in need of an angle, what you want to do is set up a trig ratio that represents the situation, and then do the inverse trig function to cancel out the trig function that's shown. Okay.